Hello everyone, my name is Michael Rubino, and today I will be talking about test-driven development. Before we talk about test-driven development, let's reflect upon the traditional testing approach. Coding first focuses on creating unit tests after the codebase has been developed. The goal is to write tests that will pass based on the code written. There can be some disadvantages to this. This can lead to writing tests that utilize shortcuts in order to pass. You can also overlook some testing scenarios or edge cases within your code. It is also harder to achieve 100% test coverage in these scenarios. Test-driven development is meant to fix some of the disadvantages of traditional code first, then test styles. In test-driven development, the unit tests are created before a developer can start developing production code. This ensures that the developer focuses more of their time on the design of the application. Another key difference is that the developer is in charge of creating all tests, as opposed to a tester. Test-driven development follows this flow, also known as the red-green factor cycle. The red and green phase is based on the color schemes when running unit tests in your IDE, such as running a JUnit test in Eclipse. You should first write tests that fail or are red, and then you should develop code to pass those tests and to make them green. The last phase is refactoring the code to ensure that you have implemented the best possible design for the solution. Refactoring ensures that you improve the design of the code, such as developing reusable code without changing its behavior. There are 3 laws of test-driven development provided by Robert C. Martin that should be followed anytime it's implemented in most programming languages. The first law specifies to write the unit test first so that you can understand and ensure that you are building a function that behaves as you expect. The second law states that you should not create more unit tests than are required to fail. This rule means that you should run the tests after each iteration of implementing the code and get feedback by the system via logs or compilation errors when necessary. While this rule can be easy to implement in languages such as Java, since compilation can be quick, it may not make sense in other languages that require a long time for compilation, such as C. The last law states that you should not write more production code than required to pass the unit test. If you continue to write code after the tests have passed, this will lead to creating even more unit tests than necessary and could lead to worse code coverage in the final product. Suppose we want to build a class using test-driven development that will verify a password has the proper requirements shown in this slide. The requirements are that it must be between 8 and 12 characters. It can also include numbers and symbols. How would we go about this problem, and what test cases would we want to implement? Go ahead and pause the video now, open your IDE, and give this a try. We will go over the steps in the next slides. I will give you 10 seconds to pause the video and figure this out. For our example, I will be writing a JUnit test. I have created a test that has a valid password with a valid length of 9 characters. Since it is valid, we want to assert the isValid function equal to true. Below the test class, we can see the first iteration of our isValid function. This function will return false and cause the test to fail, and it will ultimately show red in the end. Now, we want to get our test to pass. I will go back to the validatePassword class and think of a way to make sure the password is valid. For this person, I will create a if-else statement. If the password is greater than or equal to 8 characters, and if the password is less than or equal to 12 characters, then it is a valid password. With the logic shown in the screenshot, our test will now pass. In the previous slides, you'll notice that our IDE highlighted a couple of words in our code in yellow. This is a sign that our IDE is giving us a suggestion to improve upon our code. We can now optimize our code, also known as refactoring. For our isValid function, we can simplify the code instead of using the if-else statement. Instead, we can just return if the password length is greater than or equal to 8 characters, and if the password length is less than or equal to 12 characters. This one statement should satisfy all conditions for a valid password. We can also make some minor improvements in our testing class. Instead of instantiating the validatePassword class, we can just call validatePassword.isValid directly. Both of these methods of refactoring can help make our code more precise and easier to understand once we continue to build out this class. Unit tests are named so since they only test one unit of code. A unit test never crosses any boundaries, as this can slow down testing. An example of crossing a boundary is hitting a REST API that requires connecting to a separate service. If this service were to go down or take a long time to load, this would negatively impact the test-driven development process. Other situations like this include hitting a database or a web service. One concept that helps developers test out in these situations is test doubles. Test doubles is a term used to describe any form of fake data that simulates real-world data that is going to be used for testing. This helps developers test since they do not have to hit services like a database or a REST API directly. There are a different number of test doubles to consider when trying to create fake data. This includes dummy, stub, spy, and mock. In the example data, we use dummy data for our password. This is considered dummy data because the password provided was a default return value. There are some downsides to only using a default return value, which is why we will get into mock data in the next slide. The example problem we just went through seemed like a relatively easy task to resolve. The password validator would not be used in real-world applications, since the requirements would be too easy to crack for hackers. We probably would have to include other requirements. This would include limiting repeating characters and forcing the user to use a combination of lowercase characters, uppercase characters, numbers, and symbols. There are also a lot more requirements, but we will not be going any further. We do not want to keep adding password tests that have different variations, as this could decrease the readability of the codebase. Another solution is to use mock data. Mock data is an easy way to substitute real-world data for testing purposes. There are many tools out there that can help a developer mock data, but some of the popular tools for Java include JMockit and Mockito. I highly suggest taking a look at the different mock tools out there in order to simulate real-world data in your testing scenarios. Maintaining code quality over larger projects can be a tough task, but luckily there are some tools to help developers. These tools can make minor suggestions, such as spelling errors or detecting runtime errors. Some of these tools offer much more useful features, such as IntelliJ. It offers a feature that can help limit code duplication. As you can see in the screenshot, it offers a suggestion to simplify our code. In the end, the tools listed on this slide have some great advantages, and I highly suggest to take a deeper dive into these if you have free time. After running through this code example, it is important to remember some of these tips to ensure successful test-driven development. Writing code in increments will allow you to catch issues earlier in the process and will ensure you are testing the right behavior. It's important to keep in mind that you are writing tests to ensure the right behavior and not to only satisfy 100% code coverage. Keep the code simple, as it will be easier to maintain down the road. Make sure you are following the test-driven development cycle to ensure you are starting development on the right path. What are some of the key takeaways about test-driven development? First of all, it's important to remember some of the advantages over traditional code-first development. This includes the fact that it will ensure the correct behavior of the code, and refactoring will allow for much more maintainable code. While this method has its advantages, it also isn't for everyone or every project, but in the end, it does produce 100% code coverage if followed correctly. That's it for this lesson on test-driven development. If you're interested in taking a deeper dive on this topic, feel free to take a look at the resources listed in this slide.